Hello everybody. Now we've done all sorts of rounding up until this point, and now we're going to look at rounding up and down. Now when it comes to rounding up and down, it's usually because of one of two reasons, but I'm going to give you both of those reasons. The first one is because it makes sense to, and we're going to get to that now when we do real life situations. And the other reason to do it is because you've been told to. So it's been specified in the question. So let's start with some straightforward questions, and then we're going to move on to the real life situations. So if we start by looking at our exercises, we are asked to round up to the nearest 100. Please bear in mind, this is not necessarily the closest 100. When we rounded off to the nearest 100, it would be to the one closest. There might be a closer 100 than the one that's upwards, but we've been told we need to go up. So we are rounding off to the hundreds column. The next 100 in the first case will be 200. Again, for the next one, the next 100 would be 300. For the number 51, the 100 that's above it is 100. Our next one, the 100 that is above that is 200. And for our last one, the 100 that's above 2,567 is 2,600. Now, I just want to use the 102 as our example. If we were to round this off to the nearest 100, we'd round it off to 100. Because it has been specified that we need to go up to the nearest 100, when we're going upwards, the next 100 that we are going to hit is 200. Now 100 is 2 units away from 102, and 200 is 98 units away from 102. We can see it's definitely not the closest 100, but it's the one we've been told to use. Now often when we do rounding like this, and we include that rounded figure into our calculation, we end up with answers that are not true. So be very aware of how far your rounded off value is compared to your original value. Let's now look at rounding down. In this case, we are rounding down to the nearest 10. So for our first 655, rounding down, it would be 650. For 982, rounding down, we'd have 980. Rounding down to the nearest 10 from 11 would be 10. Rounding down to the nearest 10 for 109 would be 100. And rounding down to the nearest 10 for 4,099 would be 4090 or 4,090. We can do this for decimals too. In our first question, we asked to round the following numbers up to the nearest whole number. So whole numbers, we're looking at the digit to the immediate left of our decimal comma. We're going up, so the next number after 43 would be 44. In the next case, 18 would become 19. And once again, we are only just past 18. So 18 is the closer number, and if we're rounding off to the nearest whole number, it would definitely be 18. But because we're rounding up to the nearest whole number, it's 19. In the next part of our question, we're now going down to the nearest whole number. So 70,09 would become 70, and 10,99 would become 10. Now, just doing examples like this doesn't really teach you anything. Yes, it's good to know how to do it. It's good to follow the instructions. But when we really want to do these questions, it's about making sense of real life problems. So let's have a look at a situation. We have a class of 33 learners, and they're celebrating their goods marks. Now, Sam's mum is supplying cupcakes. The packages of cupcakes are in 6s. So each package has 6 cupcakes in, and we are asked how many packages of cupcakes will be needed. So the first thing we need to do is divide the number of learners by the number of cupcakes in the package. So let's start with that. So the number of packages that we need, and we're going to write this out, number of packages is equal to 33 divided by 6. where 33 is the number of learners and 6 is the number of packages. This is going to give us an answer of 5, 5 or 5.5. So let's think about this. 5.5, that is a number that the shop will not supply to us. We can either have 5 packages of cupcakes or we can have 6 packages of cupcakes. No shop is going to open a package and give you half of it and let you just pay for half. So the number before 5.5 is going to be 5, and the number after 5.5 is going to be 6. If we buy 5 packs of cupcakes, we are going to have 30 cupcakes, which is too little. If we buy 6 packs of cupcakes, we're going to have 36 cupcakes, which will be enough. So in this case, we are going to round up, and we are going to say that 6 packages of cupcakes will be needed. And we write that out. Now the next part of the question says, how many cupcakes will be left over? And we've kind of done a part of this already. So the total number of cupcakes, oh, excuse the writing over there, is going to be equal to the number of packages that we bought, which is 6, multiplied by the number of cupcakes in each package, which is 6, and that's going to give us 36. The number of leftovers, and I'm just going to write LO for leftovers, is equal to the total number of cupcakes that we purchased minus the number of learners that we have, which is equal to 3. So we can then say there will be 3 cupcakes left over. Now that number might not have been 5.5, and 5.5 we would have round up to 6 anyway. It won't necessarily always be the case. Once you have your answer and you need to round, take a moment and think about what makes sense. Let's do another example. We now have that the length of our classroom is 800 centimeters. We are wanting to place bookshelves down the wall of the classroom, so they're going to be end to end along the length. Each bookshelf is 150 centimeters wide. How many bookshelves can we line up against the wall? So we're going to say the number of bookshelves is equal to the space that we have, which is 800 centimeters, divided by the width of each bookcase, which is 150 centimeters. Now, if you put that into your calculator, you are going to get an amount which, once you've rounded it off, is going to be 5,33. So we're saying that 5 1/3 bookshelf can fit against that wall. But we can't shrink bookshelves, and we can't saw bookshelves off so that we just have a third. So the closest number that's going to fit in there is 5. We can't fit 6 in. It's going to be too many bookshelves. So in this case, how many bookshelves can be lined against the wall? We can line 5 bookshelves against the wall. Written very, very fast and possibly not as tidily as it should be. Okay, let's take this now a step further into a more interesting sum, as I like to put it. We are planning a school tour and there are 385 learners. Each bus can transport 50 learners. How many buses will the school need to hire? So we have our number of buses is going to be equal to our number of learners, 385, divided by the number of learners per bus, which is going to be 50. If we punch that into our calculator, we are going to get an amount of 7,7. So if we think about 7 coming before 7,7 and 8 coming afterwards, and we have 7,7 somewhere in between, 7 buses is going to be too few places for all of our learners. 8 buses is going to be too many. But because we want to include all the learners, we are going to have to make sure that there are 8 buses. So this leads to the next part of our question. If all empty bus seats are to be filled with teachers, how many teachers will be accompanying the learners on tour? So our total number of seats is given as what? It's given as the number of buses that we are going to hire, which is 8, multiplied by the number of learners that can fit on each bus, which is 50. That's going to give us the total number of seats. And we can calculate that, and that's going to be equal to 400. The number of teachers that can accompany our learners is now going to be equal to the total number of seats, which is 400, minus the number of learners, which is 385, and that is an amount of 15. I'm sure that you can see from these real-life examples that rounding gets worked into examples that you don't even realize that you're rounding. If you think about what you're doing and you've come up with an answer that makes sense, that is always your best strategy.